This lesson is going to examine polynomials and how they can be factored. So we're going to combine some of the ideas from quadratics, our basic factoring techniques, with some of the ideas we've been looking at this week, synthetic and long division, because those things also are a type of factoring. It's a way of breaking down your polynomial, dividing it into parts. So let's refresh from yesterday. We'll do some synthetic division. I can do synthetic division because I have a whole number factor. Change my sign, write down my coefficients. I don't need any placeholders. I've got all the parts and pieces. Carry down my 1. 1 times 1 is 1. Add them up, I get 3. 1 times 3 is 3. Add them up, I get negative 1. 1 times negative 1 is negative 1. And add them up, I get 0. So I could say that x cubed plus 2x squared minus 4x plus 1 is equal to our factor, and my coefficients in my next part are x squared, 1x squared, plus 3x's minus 1. Okay, there is no remainder. I've got a 0 in the remainder spot. And what I've done is I've taken an equation that was standard form and I've factored it into two different factors. Two different parts that make up the original equation. Well, that's our whole idea of factoring, right? Is to break up our polynomial into the different parts and pieces. So our objective is to do this so we can see some of those characteristics. Okay? We like factored form because we can find our zeros pretty quickly and see what kind they are. We're going to be able to use our factoring techniques at sometimes, trinomials, difference of squares, things like that, if they follow a format we're familiar with. So trinomials we can use with quadratics. Difference of squares we can do if there's two terms and there's a minus sign in the middle, we can square root. We can also common factor. That's an old technique we know how to use. When we have a polynomial with a degree higher than 2, so a cubic, a quartic, something like that, we're going to use the factor theorem to identify an initial value. In other words, we have to figure out f at something comes out to 0 so that we can start factoring this. Okay. Once we've reduced our polynomial to the degree of 2, then we can go back to our factoring techniques, trinomials, difference of squares, things like that. Okay, so we're going to try some. Today's mostly examples. So I want to factor this. Now this is not a quadratic. I see a degree of 3, so I have to start off with my synthetic division. But in this case, I haven't told you what the numbers are that divide this, right? So we're going to figure it out ourselves. So we're going to start off by trying to find a factor. I need something that makes it come out to 0. If I can find the something, then I know the factor that can be used to actually break it down. So here's a little trick for us. The numbers that make up 6, as in the divisors of 6, 1 and 6, 2 and 3, are the only numbers that could possibly be used in our factor theorem. If you couldn't use f at 4 and make this come out to 0, it won't work. It has to be a factor of the last number. So those are only the really numbers we have to try. But it could be a positive or a negative number for any one of those 4 choices. So let's start with the easy one. Let's try f at 1. That's a value, a divisor of 6. Let's see what happens. Well, 1 cubed minus 7 times 1 minus 6. Gives me 1 minus 7 minus 6. Oh, that's negative 12. That didn't work. I would get a remainder if I tried this one. Let's try the alternate option. How about f at negative 1? Negative 1 cubed minus 7 times negative 1 minus 6. Gives me negative 1 plus 7 minus 6. Hey, that's 0. That tells me that this, or if you will, x plus 1, is a factor of this expression. Okay, but you are, honestly, there's no other way around it. You have to guess and check and figure out which of these factors of 6 makes it work, remembering that it could be a positive or a negative. Okay, once we identify a factor, now we can use our synthetic division. So our number is negative 1, our coefficients are 1, no x squareds, negative 7, negative 6. And all the math we've done previously was just to get ourselves ready to try this. All right, synthetic division. Carry it down, multiply, add it, multiply, add it, multiply, add it. Okay. You better get a 0 over here, because we've proven with the factor theorem that this value, the -1, had a remainder of 0. If it didn't work, you messed up your math somewhere, either in your synthetic division or when you were figuring out the factor in the first place. Okay, so what have we figured out so far? We figured out that x cubed minus 7x plus 6, oops, we're not plus, it's minus 6, right? Minus 6 is made up of the factor we started with and this remainder part, this stuff. In other words, x squared minus x minus 6. Well, if I look at this last bracket over here, that's a trinomial. That's a simple trinomial, and I can do math with my numbers are -3 and 2. So I can take my function that I have and break it down further. X minus 3 and x plus 2. And I've taken a cubic that was in standard form and I've turned it into factored form. I can identify all my zeros just by looking at it. Okay, let's take a look at the next one. So, I have a cubic. I want to be able to factor this. I think to myself, what are the factors that make up 12? Well, it could be 1 and 12, it could be 2 and 6, 3 and 4, or any combination of those signs, positives or negatives, right? So let's try one. I always start with the easy ones first. So we'll try f at 1. We're aiming for a remainder of 0. Well, 1 cubed minus 13 times 1 plus 12, it's a plus, it's hard to see there. Okay. Comes out to, hey, 0, perfect. We've already figured out our coefficient right off the bat. It's a 1. Synthetic division, I have a cubed, I've got no squares, I've got -13x's, and I've got 12. We know it's going to come out to 0, assuming we did it right, because our factor theorem says that. So let's check it. Bring down the 1 and multiply. Add and multiply, add and multiply, and hey, -12 and 12 makes 0. So it is right. So what do we know? We know x cubed minus 13x plus 12 is made up of an x minus 1, be careful with your signs, opposite sign, times x squared plus x minus 12, which is a simple trinomial, which again has some man going on here. Multiply -12, add to 1, numbers that do that, -3 and 4. And there's our factor. We can identify our zeros, our leading coefficient, the types of zeros we have, all that good stuff that we want. Okay, let's try another one. So all we're going to do is practice these things. We're going to be good at synthetic division, good at old factoring techniques. Anyway, this time I've got myself a quartic. More parts and pieces to worry about. Same procedures. I got to think of factors that make up 64 to find my initial one. So 1 and 64, 2 and 32, 3, 4 and 16, 5, 6, 7, 8 and 8. Any one of those could be my number. Let's start with the easy one. F at 1. Well, the nice thing about ones is you can do these ones in your head, right? You're going to end up with ones in place of all the x's. So 4 plus 3 minus 38 plus 24 plus 64. Ooh. Just alone right here, I got 80, and the only negative I have is -38. There is no way that's coming out to 0. So I'm not going to figure out the math. I just know it's not going to come out to 0. Okay, let's try the next version. Let's try the -1. So -1 to the 4 is 1. -3 to the 1, sorry, -1 to the 3 is a negative value, so that's going to be a -3. -1 squared is +1. But times -38, -38. 24 times -1 is -24, and 64. Okay, positives, I got 65. Negatives, I got 65. I got 0. There's my first factor. -1. Coefficients, 1, 3, -38, 24, and 64. It better come out to 0 if I did it right. Let's try it out. Carry it down and multiply. Add and multiply. Add and multiply. Add, multiply, and 0. I did it right. So what have I figured out? I know this expression is actually the same as, I'm not going to write the whole thing, okay? X plus 1 times this stuff. X cubed, 2x squared, minus 40x's plus 64. Can I break that down further? Well, maybe. But before I can break it down further, I got to think about this kind of expression. How can I break that down? That's the cubic function. I can't apply my basic quadratic factoring techniques. I got to do synthetic division again. And I got to deal with this number 64 again. We already looked at some of these characteristics, right? 2 and 32, 4 and 16, 8 and 8. And I've already tried the number 1 and tried the number -1. I cannot use that again. Once you've used up the number, you're done with that number. Yeah, I don't really want to try 64. I think it'd be pretty messy. So I'm going to go to try 2 next. So I'm going to try this as my function at 2. Let's see what happens. 2 cubed plus 2 times 2 squared minus 40 times 2 plus 64. What's that give us? 8 plus 8 minus 80 plus 64 is 0. Hey, I found another factor. So I can do my synthetic division just on this part. So my number was a 2. The coefficients of that part are those. Let's do synthetic division. 2 times 1 is 2. Add them up, I get 4. 8, add them up, I get negative 32. Negative 64, perfect. Okay, so I'm going back to my question. The big question we started with stuff way up here. This function is made up of x plus 1. This new function, we have this one, which is x minus 2 now. And all of this stuff. X squared plus 4x minus 32. Well, now that I've reduced it to quadratics, can I do, man, let's give it a try. Anything multiply to 32 and add to 4? Yeah. 8 and negative 4. So my quartic function I had at the beginning in standard form can actually be factored into factored form with 4 separate zeros. Okay, but I had to apply synthetic division twice in this case because when I started, obviously I need synthetic division, but even my newest factor, this piece right here, still a higher power than 2, I again need synthetic division. So the higher your initial power is, the more times you probably have to apply synthetic division. I say probably because on occasion you might come across some shortcuts. And we'll see those in the next couple of days. Okay, I want you guys to practice some factoring. We need to be really good at factoring. It's one of our big skills. But now we've got a new type of factoring, right? Synthetic division. Give them a try. If you're stuck, come see me.